All right, today, lesson 54B, scale factor and similar figures. We're going to be focusing on several things today, one of them being finding a scale factor and what is meant by a scale factor. And then also we're going to utilize that information to find perhaps missing side lengths or perimeter based on some scale factor situation or maybe even area. And we'll be doing a little bit of working about explaining how we find these things. And the why am I learning this will be applied to the second part of this lesson, which will come in a few weeks. So let's go ahead and get started. Our focus lately has been with proportional relationships. Then we took that to non-proportional linear relationships, did a lot of comparing, and we're still going to be looking at both of those situations. Okay? All right, so a little bit of background knowledge. We know in full detail, if we are given a table, how to find lots of pieces of information from that, like if the situation is a proportional relationship, which we can find, remember, by comparing the ratios of the output over the input, or the input over the output, but output over the input is the better one because in most cases that is our constant of proportionality or our constant multiplier. And that idea of a constant multiplier or a multiplier is not going away because we're going to apply that today. And once again, we could also compare input over output, but that only gives us the constant of proportionality going the other direction. And the better unit rate here is clearly cost per book. But in both situations, it gives us a constant multiplier. So today, part of what we're talking about are similar figures. And similar figures are, and we have blank areas in the notes to fill in, figures that have the same shape but not the same size. In other words, usually one may be an enlarged version of the other or maybe a reduced version of the other. Or as I put in your notes, one is a blown up, which means enlarged version of the other. So the most simple case that I could think of would be a situation like this, where we have a rectangle that was 100 by 50 and it has been enlarged or blown up to be 200 by 100. Those are similar rectangles or similar figures. And to figure out by how many times the enlarged version has been blown up, that is something that we call the scale factor, which is the ratio of any two corresponding lengths in two similar figures. So what if I ask you, going from the left rectangle to create the right rectangle? The scale factor tells us by how many times did we multiply the side lengths with the rectangle on the left to make this rectangle on the right. So what would that be? 2 times bigger, right? Because 100 times 2 is equal to 200, and 50 times 2 is equal to 100. So the scale factor mapping the left rectangle to the right rectangle is clearly 2. But what if I flipped that? What's the scale factor mapping the right rectangle to the left rectangle? It's 1/2, right? Because of the fact, and this just sort of tells you one reason why we kept going both directions for our constant of proportionality, our unit rate, and our equation, because depending on which direction you're going to find scale factor, one is the reciprocal of the other. Okay? All right. So this problem right here is not in your notes. So just look up here, please. One of the things that we're going to be trying to do today is assuming that what we have here are two similar rectangles, what would the side length have to be? In other words, the side length that says x, what would that have to be to make sure that they are similar to each other. Now, some of you have your hands up, but what I'm going to have you do is I'm going to have you have a quick conversation with your shoulder partner about what it is and why you think it is what it is. Go ahead. Okay, so a lot of what I heard, and I heard somebody over here, I think it was Elizabeth, who said that, well, 18 times 4 is 72, so 7 times 4 is 28. Is that what you said? Yeah, that's what I thought. And so that is essentially the multiplier to get from the left rectangle to map that onto the right rectangle. And so the missing side would have to be 28. And so what that leads us to is that leads us to the scale factor of mapping the left rectangle to the right rectangle. Since the multiplier was 4, the scale factor is 4. And if we were to reverse the order and map the right rectangle to the left rectangle, of course, that would be 1/4. So when in the homework, when you are asked for scale factor, you have to pay attention to which direction you're going because it does make a difference. Okay? Now, one other quick thing. If we were to check the ratios, because this is what, since last year, the common theme has been equivalent ratios. So if we compare the ratios of the corresponding side lengths, and corresponding side lengths are side lengths that line up with each other. So what I mean by that is this side corresponds to this side, which is why we have 18 over 72. And in addition to that, this side corresponds to this side. So if this is all working, we've done everything correctly, our ratios of side lengths, in this case, of our corresponding side lengths for our small rectangle compared to our larger rectangle, they better be equivalent, and they are. 18 over 72 is equal to 7 over 28. And then there's a strong correlation between that and scale factor, which we will come back to. All right, so everybody try number 1. Okay, I'm about to have you shoulder partner the missing side length. And when you do that, I want you to talk about why you think it is what it is. And then I also want you to do what I've talked about in the previous 2 problems. Talk about what the scale factor would be mapping the left rectangle to the right rectangle. And then what would the scale factor be mapping the right rectangle onto the left rectangle. So 3 things. Missing side length, scale factor one direction, scale factor the other direction. Go ahead and exchange with your shoulder partner, please. All right, so to get from 18 to 6, the multiplier is 1/3. And so 24 times 1/3 will give us 8. Okay, so the missing side length is 8. So now if we were to find the scale factor mapping the left rectangle to the right rectangle, well, clearly that would be 3 because 6 times 3 is 18. And our new side that we just found, 8 times 3 is 24. Going the other direction, mapping the right rectangle to the left, well, that would be 1/3, and the work is still up there for that. And so, before we try the next problem, we have to come back to an idea, and I'm going to write it right here. We've done lots of problems where I may have had to do something like this. 2 over 7 equals 5 over x. And when we were solving proportional ideas like that, we were doing it with a multiplier. And so what we were doing the first time around is we were trying to figure out, well, what do we have to do to 2 to make 5? Well, the multiplier there would have to be 5 halves. 2 times 5 halves gives us this 5. And so we had to do the same thing right here to figure out that x is equal to 35 halves, which then gave us our equivalent ratios or our proportion. 2 over 7 is equivalent to 35 over 2. And so as these types of similar shape problems get more complicated, we have to sort of go into that mode of thinking, the same mode that we thought of in terms of solving proportions. So let's try number 2. I'm telling you that triangle ABC is similar to triangle DEF. Please find the side that is represented by x. So as you are figuring this out, this is clearly more complicated than number 1 was, or the example that I gave you, where the multiplier was a whole number. But it's the same kind of thinking, and it's also the same kind of thinking that we had to do when we were solving some of the proportional problems where I asked you what the multiplier was. And so when we shoulder partner this one, and then I'm going to add another one to our lesson that we're going to have to draw the picture for, not only are you shoulder partnering what you got for the missing side, but you're shoulder partnering, once again, how you got there. And in this case, you would need to talk about what multiplier you used to get there. So go ahead and shoulder partner, number 2. All right, I heard lots of good discussion there. I heard lots of good discussion about what the multiplier was. So essentially, we're trying to figure out here, since these are the two sides that I know, I'm trying to figure out what do I have to do to that 12 to make that 10, because whatever I do, I have to do the same thing to 8 to find that value right there. And so the multiplier is 5 6. Now, some of you left it as 10 twelfths, and that's fine. You're going to get to the same place that you need. So if you use 10 twelfths, you're still going to get where you need to be. So my multiplier is 5 6 to make 10. 12 times 5 6 is 10. And so 8 times 5 6 is 40 over 6. But 40 over 6 is 20 thirds or 6 2/3. And I don't care whether you leave it as 20 thirds or write it as 6 2/3. And so if we compare our ratios now, we truly do have a proportional situation now. 12 over 10 is equivalent to 8 over 6 2/3. Now, what is the scale factor of the large rectangle? So we're mapping the large rectangle to the small rectangle. 5 seconds with your shoulder partner. Go. Right. If we were going from the triangle on the right to the one on the left, it would be 6/5. But going from the large one, which is the triangle on the left, to the one on the right, 5 6 is our scale factor. All right, so this is the one that I want you to add to your notes. You should have enough room down next to number 2. So can you quickly draw this picture? And then find the missing side length. All right, so before I talk about this with the multiplier method, when you get these in your homework, the majority of the problems, you're just asked to find the missing side. And there are lots of ways of finding the missing side, okay? So one other thing you can do, and I call this the looking within method. If you look at the relationship between this side and this side, do all of you see that this side right here is 8 times as big as this side? Yeah? Well, if these two shapes are supposed to be similar to each other, the same has to hold here. This side over here better be 8 times as big as that one. So you should always look for situations like that too, because sometimes you luck out and those are the numbers you get. Now, sometimes not, okay? But always look for that. So let's go back and do this with the multiplier method. It takes 2 times 41 halves to make 41, and so 16 times 41 halves will give us, if we do the math there, 324. So the missing side is 324. And then if I ask you for the scale factor, which I had you do when you were shoulder partnering, that will map figure A to figure B, of course, that will be 41 over 2. And that's one reason why we need to find that multiplier, because it ends up being the scale factor. And if you were asked to go the reverse direction, the scale factor, of course, would be 2 over 41. Okay, so next is basically a little bit of practice of being given a shape, being given a scale factor, and then drawing a new shape. So in number 3, we have rectangle ABCD. And we're asked to draw a rectangle with side lengths twice that long. Well, if I'm going to do that, that's the multiplier or the scale factor. And then we're going to label it EFGH. and then we're going to find the perimeter and area of each. Well, in order to do that, you would need to find how long it is from here to here, which looks like it's 1, 2, 3, 4, 5, 6, 7. And then from here to here, it looks like it's 1, 2, 3, 4, 5. Now you need that because on the grid to the right of that, you want to draw, and it can just be anywhere in there. In the homework, I restrict you a little bit more than that. But if we're going to draw this shape twice as big, then the side lengths need to be 14 by 10 because we're enlarging it by 2. So could I get all of you to go ahead and do that? And it can be anywhere within that grid. Like I said in the homework, I'm restricting it a little bit more for you. But here you can just draw it anywhere within the grid. All right, so your new drawing should look something like this. You just have to make sure that it's 14 by 10. Side lengths are twice as big because the multiplier is 2 or twice, which also, of course, is the scale factor. And we were supposed to label it like this, E, F, G, H. The perimeter of the original is 24 units. The area is 35 square units. The perimeter of the new one is 48 units, and the area is 140 square units. Now, I'm not going to go into full detail on this, but we will in the next part of this lesson, which is in a couple of weeks. Notice that the perimeter is twice as big, which happens to be the same as the scale factor. But the area is not twice as big. The area is 4 times as big, which happens to be the twice squared. But once again, we're going to come back to that in the second part of this lesson in a couple of weeks. And then the scale factor from right to left, of course, is 2. All right, here's what I want you to do. There are 4 problems left where you're basically doing the same kind of thing. Go ahead and do number 4, 5, 6, and 7, and I'll get back to you in about 5 minutes. All right, so once again in number 3, the scale factor was 2 because that was essentially our multiplier, and that came from within the problem right there. So I wrote 2 to 1, which I don't think we're really interested too much in writing it with a colon, so the scale factor is just 2. All right, and then number 4, you were supposed to draw a new rectangle with side lengths half as big, which clearly means the scale factor is going to be 1/2. So our new rectangle should be 5 by 8. And if you were to find the perimeter, notice that the perimeter is half as big, right here. Multiply by 1/2. But the area is 1/4 as big. In other words, the 1/2 squared. But we will come back to that in more detail at a later day. And our scale factor, of course, is 1/2. All right, number 5. Our rectangle looks like this. We're creating a rectangle with side lengths 3 times as big. So it better be 21 by 10.5. And since we were enlarging it by 3 times, that means our scale factor is also 3. Notice that our perimeter is 3 times as big, but our area is 9 times as big. Number 6, the original was 2.5 by 3. We're enlarging this 4 times, which happens to be our scale factor. So our new rectangle is 10 by 12. If we compare the perimeters, the perimeter is 4 times as big, same as the scale factor, but the area is 16 times as big. And once again, our scale factor is 4. And then number 7, 1/3 as big for our new one. So it better be 5 by 3. 1/3 is the scale factor. The perimeter would be 1/3 as big, but our area would be 1/9 as big. 15 is 1/9 of 135. And that was the last problem. We are finished for